Hello. Are the things visible now? Am I audible? You can keep your message in the chat box whether I am audible or not. Okay, that's better. That's good. I am audible. Am I visible clearly? Am I visible? Okay, that's good. So there was some technical problem during the earlier session. Those were scheduled. So due to which you were facing a lot of difficulties to join the session. Yes, I am clearly now audible and visible to all the students. So that's good. So we can definitely say that the problem that we are facing in the last half an hour, so we have overcome that problem. So I can see that 9 students have yet joined for this particular session. So somebody from you put the message on our group to join the session for the power plant engineering. Okay, I request anybody from the student to put the message on our WhatsApp group and insist the students to join for the this delayed session, even though for the power plant engineering. I will share my screen and please let me know that whether my screen is there visible. Is the screen visible? Yes, that's good. The screen is visible now. So let me start with the this today's particular session for the power plant engineering. And this is the first interaction that we are having for this particular first semester of the new academic year. The objective for today's interactive session is to let you know about the subject that we are going to teach, that we are going to learn in this semester of the power. In this semester, that is the power plant engineering. This subject would be essentially consisting of the two different parts. One that is nothing but the theory that we are going to study, and the subject title being power plant engineering. And the another part of the subject is there for the power plant engineering laboratory. So the objective here would be to discuss what the things that we are going to see in our subject of the power plant engineering. And if possibly the time permits, toward the end of the session, we can directly start with the contents for the unit number 1. If you find any problem, any difficulties during the this particular session, just send me the message so that it will be possible for me to take any corrective, suitable action from my end. Okay. So the power plant engineering, the subject which is offered there you at the final year, the semester 1, and the code for the subject is 17 BTME 702. So this code is there for the theory subject that we are having. We will be having a very broad discussion regarding the teaching, examination or the evaluation scheme, the different contents for our subject from unit number 1 to the unit number 5, the different textbook or the reference book which are supposed to be used for the preparation for the study of the power plant engineering subject. As far as the teaching scheme is concerned, so according to the syllabi for the power plant engineering, we are having the 4 lectures in a week, and there would be a practical session of the 2 hours per week per batch. Now, considering the present circumstances, we are not as such starting with the practical sessions for the power plant engineering, but we will be conducting the theory lectures initially, and when the things become somewhat easy for us, somewhat practical for us, then we can start with the practical sessions for the power plant engineering as well. So you need not to worry that when the practicals are going to start or when they will be finished. We will be definitely taking care of the practicals at our end as well. The examination scheme will be consisting there for the examination of the uh, practical power plant laboratory as well as the power plant engineering subject. And the first two lines which are there for the evaluation examination scheme for the practical, that is power plant engineering laboratory, I will say. The end term practical examination, that is of 60 marks, as your batch is there for the 2017 pattern. So you will be having the end term examination, practical examination of 60 marks. This practical examination will also consist of the oral based as well. So it will be the combination of the oral and practical session rather, instead of only the conducting the practicals. So questions will be asked based upon the practical and based upon the entire sets of the practicals that we are conducting in the subject of power plant engineering laboratory. And there is a continuous assessment for the practicals, whose weightage is there for the 40 marks. So your regular attendance for the practical sessions, then the way in which you are writing your journal, the results, the conclusion, the graph that you are say expressing in your own words. So that will be carrying out for the assessment of 40 marks. Maybe we are having the midterm practical examination as well. So these first two lines are there for the practical examination assessment, 60 marks and 40 marks respectively, thus comprising of the total 100 marks. And then the evaluation for the theory course, power plant engineering theory subject. Midterm or the in-semester examination of 30 marks, and comprehensive examination, which is based upon the entire syllabus, unit number 1, 2, 3, 4, and 5, all the units. So comprehensive end-term examination toward the end of the semester, having the weightage of 60 marks, and the continuous assessment for the theory, that is 10 marks, so which is based upon the assignments which will be say given to you on the different units. Sizable number of the theoretical questions as well as the numericals will be covered as a part of the assignments for the different units, and these assignments will be evaluated, or the continuous assessment will be carried out for the 10 marks. So this will be the 30 plus 10, that is a continuous assessment, 40 marks, and 60 marks is there for the end term examination. Okay. Now in the forthcoming slides, we will see what are the syllabus, and we will discuss what points that we are going to study, what points we are going to focus for the subject of the power plant engineering. One by one, we will see what are the contents, and if possible, at the end of this discussion for these contents, we can definitely start with the discussion on the unit number 1 for the power plant engineering. Unit number 1, that is the title there for the introduction. This unit number 1, that is divided into the two different subparts or the subheadings, I will say. The first half part that highlights here as in power generation. So we are going to see or look at the what is the scenario for the energy consumption, energy generation across the world or global scenario, worldwide scenario. Then the current status of the power generation at the national level and at the state level as well. It means that what is the installed capacity for the different power plants at the national level, consisting of the different modes of the power generation, different methods of the power generation, and the same will be taken into consideration, will be taken into the discussion at the state level as well. Then the role of the government and private power generation organization. So we know that there would be some power producing companies, electricity generation companies, which are maybe the government sector companies or the public sector organizations that we call as, and the private sector organizations, private sector companies also. These government organizations will be of the two different types. One organization that may be say working at the national level or the central level, we can say, and the another government agency that may be working at the state level, that we normally call it the state electricity boards. So So we'll be looking at what are the roles which are played by these different government and as well as the private organizations which are involved in the power generation business. And the first part for the unit number 1. The second part that deals with the economics of the power generation. It means that how much cost that we have to incur for the generation of an power. It means that right from the installation of that particular power plant till the energy is transmitted and distributed till the end user. So what are the different costs that should be taken into consideration for this entire process? So we'll be having the introduction for the economics of the power generation, why we should consider the economics of the power generation, why it is important for us. Then the cost of electrical energy, how to calculate the cost of the electrical energy and why it is important for us to calculate the cost of the energy. Different types of the cost incurred. So what different there would be either the fixed cost or the variable cost at very random level. I will say different types of the cost which are incurred and their calculations. So different formulas, different equations that we'll be looking at for the calculation of this electrical energy of the generations. So selection in the type of the generation, it means that for which particular type of the power plant you should go. In the next coming slides, when we'll start actually with the discussion on the unit number 1, we'll be definitely coming to this point, that is a type of the generation or the type of the power plant. Those are available for us and on what basis they should be selected, what should be the consideration for the selection of such types of the power plants. Then the performance and operating characteristics of the different types of the power plants and the different tariff methods. So tariff methods are nothing but the methods which are used to calculate the cost of the electrical energy depending upon whether the consumer is the domestic consumer, whether it is the commercial consumer or whether it is the industrial type of the consumer. So depending upon the type of the consumer, different tariff methods would be applicable for the calculation of the electrical energy or the cost of the electrical energy. So these are the highlights for the unit number 1 that we are going to look at. As far as the first part is concerned, so it is totally the theoretical one. Okay, need not to worry about that. And for the second part, so definitely some simple mathematical formulas and the equation would be made use of for the calculation of the cost of the electrical energy. So definitely some numericals will be involved there in the part 2 for the economics of the power generation. Then unit number 2, we will be switching on to the different types of the power plants. Okay, we'll be looking at what are the different types of the power plants which are available for us to generate the electricity. And out of that, one of the power plant is nothing but the thermal power plant, also called the steam power plant. The different points that we are going to study here are again categorized, or they are being divided in the 2 different parts. Looking at the first paragraph on this particular slide, layout of the modern thermal power plant with different important circuits. It means that this layout will be used to show what are the different components of the thermal power plant, where they should be placed, where they should be located in actual operation of this thermal power plant. What is the role of this particular equipments which are used in the thermal power plant, in the working of the power plant, working principle of the power plant, that I will say. The working principle of the thermal power plant will be based upon one thermodynamic cycle. And if I am not wrong, the thermodynamic cycle which is used for the operation of the thermal power plant, that you might have definitely studied there in the subject of the engineering thermodynamics at the second year. The other part for the this unit number 2, the type of the coal used, the different types of the coal, different qualities of the coals which are used for the generation of steam, and then converting that steam into the electricity by operation of steam turbine. The coal handling and the ash handling techniques, fuelized bed boiler. So these are nothing but different types of the boilers which are used to burn the fuel and generate the steam from the water, and that steam would be indeed used to operate the thermal power plant, steam power plant, we can say. Just a minute ago that I have said the thermodynamic cycle that is used for the operation of the thermal power plant is the Rankine cycle. So to improve the performance of the Rankine cycle, to improve the efficiency, thermal efficiency, overall efficiency of the Rankine cycle, so we will be having some different modifications. Some improvements would be done in the basic cycle. So those improvements or those modifications would be comprising essentially of the different arrangement, and two different arrangement that we can discuss here, that we are going to discuss, are with the reheat and the regeneration. So in brief, we can say that the reheat and the regeneration are nothing but an mechanical arrangements which will be used to improve the performance, which will use to improve the thermal efficiency of the Rankine cycle, the output from the Rankine cycle. In the cogeneration power plants, the cogeneration power plant, the purpose of the cogeneration power plant is nothing but, along with generating the say the electrical energy, the power, the input, the fuel input which is required for the cogeneration power plant will be essentially obtained from the waste of some other type of the processing plant, like that of say the sugar industry. The bagasse which is available after the extraction of the sugar cane juice, so that bagasse is essentially used for the operation of the thermal power plant. This bagasse will be burned, the thermal energy generated will be used to convert the water into the steam, and then that steam would be converted, will be passed through the steam turbine and will be converted into the electrical energy. So that is what we are going to look at there for the cogeneration power plants. We will be looking at the significance or the importance of the cogeneration power plants, why they are needed. The second half part for this thermal power plant, that essentially concentrates or focuses on, I will say, one of the very important component of the Rankine cycle or the thermal power plant is nothing but the steam condenser. Okay. Condenser, so as the name itself indicates, to change the phase of a substance, to change the phase of a working fluid from the vapor state to the liquid state, to condense the steam, to change the phase of the steam from the vapor state to the liquid state, the liquid water. So that is the steam condenser. So what is the necessity, why you need the steam condenser in the thermal power plant, that we are going to discuss. The different types of the classification of the steam condensers used in the thermal power plant, the different mechanical arrangement, the differences between the different types of the condensers used in the thermal power plant, the cooling water requirements, the condensate which is obtained after the condenser will be used as and say the cooling water, condenser performance parameters, that is to calculate the efficiency of the steam condenser, normally called the vacuum efficiency, the performance parameter, calculations of the performance parameters for the condenser that we will discuss. The cooling tower. So cooling tower is also nothing, we can say that it is one type of the heat exchanger used in thermal power plants. These cooling towers can also be seen widely used for the operation of the nuclear power plants as well, isn't it? The water which is circulated need to be get cooled with the help of the cooling tower. Then the effects of the air leakage on the condenser performance and its calculation. One line that I would like to just highlight here for this last part. The condenser normally operates at the pressure nearly pressures which are below atmospheric pressure, that is a vacuum. And it is desirable that this vacuum must be maintained in the condenser, and there should not be any air leakage from the surrounding, which is normally at the barometric pressure, atmospheric pressure. So this high pressure air should not enter, should not get leaked inside the condenser which is at the lower pressure. And if such things are happening, it means that there is a leakage of the surrounding high pressure air into the low pressure condenser, inside the low pressure condenser. Then what are the effects of that one and the calculations of this one. It's whether the efficiency of the condenser is going to be affected or whether the operation of the condenser is going to be affected due to the effect of this air leakage. So some numericals would be involved there, not only in the first part of this unit number 2. Okay, so that is nothing but the numericals would be there with the Rankine cycle. Okay, Rankine cycle and the Rankine cycle with the reheat and the regeneration. One more thing that I would like to insist to all of you, that while solving the problems or the numericals on the Rankine cycle with the reheat and regeneration, you should be very well conversant, or you should be very much adaptable with the usage of the steam tables. Okay, because the different pressures and the temperature of the steam would be rather mentioned to us at the different levels that we need to get the values of the enthalpy, maybe the entropy, or say the temperature, or maybe the dryness fraction, superheated temperature. So these parameters would be required for the calculation of the performance of the Rankine cycle. So you should be very well conversant, should be very much adaptable with the usage of the steam table. So I would like to insist that you please go through the steam table, how to make use of the steam table, and at the end of the steam table, one chart is also attached there. So that chart is nothing but the enthalpy entropy diagram, also known as the Mollier diagram or the Mollier chart. Okay, some of the properties can also be known from the Mollier diagram as well. So you should be perfect to know the properties of the steam, not only from the steam table, but from the Mollier diagram as well. So that will be required for the Rankine cycle. It will be also required to know the performance of the condenser and the performance of the cooling tower and their calculations. Okay. So that is their content for the thermal power plants. This unit number 3 that particularly highlight there for the 3 different types of the power plants. Okay, all 3 types of the power plants are combined here in unit number 3, and these are nothing but the conventional type of the power plant, I will say: hydroelectric, nuclear, and diesel power plant. So the different information that we are going to highlight there for such types of the power plants are mentioned here in this slide. Site selection for the hydro plant or hydroelectric power plant, I will say. So before you install a hydroelectric power plant at a particular site, you should make a detailed survey of the site, that whether this particular site is feasible or whether it will be possible for us to install the hydroelectric power plant. The different parameters need to be taken into the consideration, isn't it? So site selection parameters, then the types of the hydroelectric power plants, the different mechanical arrangements that we will see there for the hydroelectric power plants, then their advantages, disadvantages, merits and demerits based upon the different types of the power plants. Then these 3-4 words which are mentioned there: hydrograph, flow curve, flow duration curve, and mass curve. So these are nothing but the graphical representations of the various parameters which are used for the evaluation of the hydroelectric power plants: hydrograph, flow curve, flow duration curve, and mass curve. So normally the data would be available in the tabular format, and based upon that tabular format, the different types of the curve would be plotted. We will see what type of the information that we can get from these various types of the curves, or what is their importance, what is their significance in plotting these types of the curves. So that is the objective for this first paragraph for the hydroelectric power plants. Nuclear power plants and its components, it means that the different parts, different elements which comprises the nuclear power plants, which make the cycle operationable for the nuclear power plant. One of the important element for the operation of the nuclear power plant is nothing but the nuclear reactor itself. Like that of in the thermal power plant, you are having a boiler which burns the fuel, the conventional fuel, like that of the, say, the coal or the oil. So instead of the boiler, here in the nuclear power plant, It is nothing but the nuclear reactor, where you are having the nuclear fission of the nuclear fuel that would be taking place, and it would generate the thermal energy. Heat would be generated. So we will be looking at the different types of the nuclear reactors, their arrangement, and their advantages and the disadvantages one over the another. Different types of the nuclear fuels used, the moderators, the role of the moderator in the operation of the operation of the nuclear power plant, different types of the moderators which are used in the nuclear power plants, coolants. The coolants are essential so that the temperature of the nuclear reactor should not exceed above the safe limit. So you should continuously take out the heat from the nuclear reactor so that it will be maintained at the desirable temperature. So the different coolants that we are going to discuss there, either it may be the liquid or it may be the solid, it may be the gas as well, gas to reactors. Control rods, the function of the control rod, the materials which are used for the control rod. So that is what the matter of the discussion is there for this second part. And the nuclear waste and disposal. So that is one of the very important topic for the nuclear power plant or for the operation of the nuclear power plant. Merits and demerits of the nuclear power plants. What are the different advantages and the disadvantages of this nuclear power plant as compared to the different types of the power plants? Different means in the earlier unit, that is the thermal power plant. So how the thermal power plant can be differentiated with the nuclear power plant based upon its advantages and disadvantages. How you can compare the hydroelectric power plant based upon the merits, demerits with the nuclear power plant. Similarly for the diesel power plant as well. Okay. So comparison will be carried out with the nuclear power plant with the other types of the power plants as well. Diesel power plant, the third part for this unit number 3. The layout for the diesel power plant, how the components are arranged in the diesel power plant, their block diagram that we will see. The performance analysis. So some calculation part, mathematical part would be involved here. Some equations would be used to determine the performance of the diesel power plant. And I am sure that while learning the subject of the applied thermodynamics in the second year, you might have definitely carried out some calculations for the diesel engine or the trial which is made on the diesel engine, isn't it? So we will see from the different perspective as far as the power plant engineering is concerned for the performance analysis of a diesel power plant. The different applications of the diesel power plant, their advantages and disadvantages, the merits and demerits of the diesel power plant. So I would say that this entire topic is quite a lengthier one, and some of the numericals would be involved there for the first part, that is nothing but the hydropower plant, and in the third part, that is there for the diesel power plant, diesel electric power plant. Okay. Unit number 4. So it is there for the what you can say, the non-conventional types of the power plants. Now till now we have listed 4 different types of the power plants: the thermal power plant, hydroelectric power plant, nuclear power plant, and the diesel electric power plant. So all these power plants are considered to be the conventional types of the power plants. So while discussing these power plants in details, we will be looking at their advantages and disadvantages, pros and cons of these power plants. And this is one of the very interesting topic for the power plant engineering, that is non-conventional power plants. The energy which would be obtained from the non-conventional power plants or the renewable energy power plants. Now in the upcoming slides, when you will start with the unit number 1, you can definitely come across some statistics that how there is a trend of shift from the conventional power plant to the non-conventional power plants, or the more importance, more significance is given there for the non-conventional power plants in the coming years, the coming days, to overcome the problems which are arising due to the usage of the conventional power plants. 3-4 different types of the power plant that we are going to highlight, we are going to study. under this unit number 4. Wind power plant, wind measurement. What is the technique for the measurement of the wind? That is nothing but the wind velocity, rather, I will say. Different types of the wind machines, different configurations, different arrangements for the wind machines or the wind turbines, and where these different arrangements can be suitable, how they can be compared, and how to make use of these different arrangements. Then the site selection, and I would say that site selection is nothing but very important parameter before you select, before you go for the installation of a particular type of the power plant, whether it is the thermal, whether it is the hydroelectric, whether it is a nuclear, or whether it is any type of a non-conventional power plant. So you must carry out some survey, you must carry out some preliminary study that whether this particular site for which I am looking, is it really suitable, is it really worth that I can install that type of the power plant here. So that you have to study initially. Then the solar power plant, also known as solar thermal power plant in some of the books. The components of the solar thermal power plant, solar power plant. The important component is nothing but the solar collector. So we'll discuss the different types of the solar collectors, their different arrangements, what are the advantages and the disadvantages of these different types of the solar power plants, what is the scope of these collectors, rather, not the solar plant, the different types of the solar collectors in actual practice. The solar photovoltaic system, so that is different than that of the solar collectors. We'll see that how the solar photovoltaic system actually works, which is used in generation of the electrical energy, electrical power. Then other very uncommon, that I will say, non-conventional types of the power plants, tidal power plants, which make the use of the tides which are available from the ocean. Then OTEC, ocean thermal energy conversion, the thermal energy which would be available from the ocean. The geothermal power plants, MHD plants. MHD stands for magneto hydrodynamics. So magneto hydrodynamic plants, the fuel cell, and the hybrid power plants. So all these are nothing but the non-conventional power plants. These are very uncommon, I will say. Then toward the end of this unit number 4, we'll be looking at what are the future challenges that we are going to face for the non-conventional power plant, for the installation of the non-conventional power plants, considering their capacities and considering their modifications, their efficiency, then what you can say, the reasonable cost or the rational cost of the generation, okay, the cost of generation, that I will say. So all these are nothing but the challenges or the technology that is available for the conversion of the available energy into the electrical energy. So that cost is of important to us. So that is nothing but what the challenges that would be having. So the technology cost should be as low as possible so that it would be affordable to the maximum number of the occupants or maximum number of the consumers, rather, I will say, and their cost would be the reasonable one. This unit number 5, so that is the last unit for our topic for the power plant engineering. Environmental impacts of the power plants. So environmental impacts which are normally there from the operation of the conventional types of the power plants, that is the concerns, impacts which are arising due to the operation of the thermal power plant, due to the hydroelectric power plant, nuclear power plant, diesel power plant. So how they are affecting the ecosystem, how that is affecting the human life, how that is affecting the flora and fauna as well, how that is affecting the aquatic life. So all these parameters need to be taken into consideration, which is nothing but the environmental impacts of these power plants. So different aspects that we are going to take into consideration for this one: the constituents of the atmosphere, the different pollutants which are released for the thermal power plants, what are their effects on the human life, animal life, aquatic life, agriculture. So these are nothing but the different sectors or the different fields which are going to be affected by the pollutants which are released from the thermal power plants. Then environmental control of the different pollutants, what techniques which are available for us, what modern methods are available with us or would be available with us to control the different pollutants such as the particulate matter, PM, oxides of the sulfur, nitrogen, which are considered to be not so environmental friendly. So we should tackle with this one. Then the issue of the global warming and the greenhouse effect. Okay. So it has been say arising due to the release of these poisonous gases which are obtained after the burning of the fossil fuels, conventional fuels. Thermal pollution, increasing the temperature of the surrounding air, increasing the temperature of the ocean water, that we'll say, and its control as well. Other types of the pollutant resulting from the different types of the power plants. Between that, the pollutant which are say resulting due to the operation of the nuclear power plants. The radiations which are normally uh, uh, released from the nuclear power plant. So that is nothing but the pollutant from the nuclear power plants. So that also we are going to have as a topic of the discussion under the environmental impacts of the power plant. Okay. So these are some of the contents for that from unit number 1 to the unit number 5. I will say that this unit number 5, in this unit number 4, these are entirely to be of the theoretical nature. Then the unit number 3, so some numericals would be involved there for the hydroelectric power plants, the diesel power plant. Unit number 2, definitely, I said earlier, I will recall that one, the operation of a Rankine cycle with the reheat regeneration, then the cooling tower, calculation of the performance of the cooling towers and the condensers. And in the first part, that is nothing but for the economics of the power generation to calculate the cost of the electrical energy, the different methods which are available for the calculation of the electrical energy, that is the direct methods. So these are nothing but the contents as far as the unit number 1, 2, 3, 4, 5 are concerned. So I would say that around 35 to 40% weightage is there for the numericals, and the remaining 60-65 percentage of the weightage is there for the theoretical aspects of the subject of power plant engineering. Okay. As I mentioned at the beginning of the session, the another part of our subject is nothing but the power plant laboratory. That is the practical part. So the course code for that subject is 17 BTME 711. Okay, that is the power plant laboratory. This particular slide shows the different experiment which are the part of the power plant engineering laboratory. And out of these 10 number of the experiments, we are going to cover any 8 experiments. Okay, and the 2 assignments can be performed. So almost everything is compulsory. We will say that industrial visit to the thermal cogeneration power plant. Now we have to check out the appropriate time in this post-COVID period, that whether it would be really visible for us or whether we will get the permission from the concerned party, either any thermal power plant or the cogeneration power plant. So depending upon those situations, the industrial visit is likely to be arranged. So at this moment, we cannot say that anything firm right now. Same there for the 1 or the 2, industrial visit to the thermal cogeneration power plant, industrial visit to the gas turbine hydroelectric power plant. For the last year batch, we had the visit there for the cogeneration power plant at the sugar factory at Malegaon, okay, near Baramati. Then 2-3 study experiments are there. Study of the fluidized bed combustion boilers, okay, the different arrangements for the fluidized bed combustion boiler, their advantages, their disadvantages, and their applications. Then the 2 trials are there. Trial on the steam power plant, trial on the diesel power plant. Study of the power plant instrumentations. So power plant instrumentations are nothing but the different instruments or the techniques which are used for measurement of the various parameters for the safe operation of a thermal power plant, or say the particular any type of the power plant. Pressure gauge, nothing but one of the instruments. Then the temperature, then the flow, of any particular gas, flow of a steel, then the RPM of an say a turbine, isn't it? So these are nothing but the different parameters that should be recorded while the operation of the power plant takes place, isn't it? So study of the different power plant instrumentation will be came across. In the study of the high pressure boilers, so high pressure boilers which are used in the operation of the power plants which are used for the generation of electrical energy. Case study of the non-conventional power plant. Then the two assignments are there for the practical subject as well. Assignment on the environmental impacts of the different power plant and assignment on the mathematical modeling and performance analysis of the power plant. So by using any suitable software or the programming, you can say the programming language, you can solve that mathematical model, enter some input parameters and get the performance parameter, plot them on the x versus the y axis and make the comment based upon the trends that you obtain from those graphs and write down the conclusions in your own notes. So that is what the tentative background, the broad background for the power plant engineering laboratory. And coming to the textbook or the reference books which are supposed to be used for the preparation for our subject for the study purpose. 4 or 5 different books are suggested in our syllabus for the power plant engineering, our university syllabus. I will name some of them. P.K. Nag, the name of the author, and the title of that book is the Power Plant Engineering. It is one of the good book for the power plant engineering. Then the comprehensive information as far as the theory and the numericals are concerned for our subject, the second book would be the most important for us. A course in power plant engineering, and the authors are nothing but Dumkunwar and Arora. Okay, a course in power plant engineering by Dumkunwar and Arora. Power plant engineering by R.K. Rajput, the another very good useful book for the power plant engineering. Then book number 4 and book number 5. So book number 4 that essentially will be helpful for the unit number 4, that is the non-conventional power plants, I will say. So non-conventional energy sources. That is the title of the book. And the author of that book is nothing but the G.D. Rai. Then one of the non-conventional power plant is nothing but the solar thermal power plant. So utilization of solar thermal energy, that is nothing but the title of the book. And the author is there for the S.P. Sukhatme. So book number 4 and book number 5. So those would be helpful for you to study the non-conventional types of the power plants. And book number 1, 2 and 3. So those would be helpful for the conventional power plants. That is unit number 1, unit number 2, unit number 3 and unit number 5. So the second book, that is nothing but the comprehensive book, which will cover almost all the topic, maximum topics from our subject of power plant engineering. I would strongly recommend all of you to use this type of the book. So these were what the content that we are having for our subjects. Very broad introduction to the subject of the power plant engineering, background for the power plant engineering, that I will say. And now still some time is there with us, so that definitely we can begin. We can start with unit number 1 for our subject of the power plant engineering. Having carrying out the discussion in the further 10-15 minutes, if you feel any point that is being important, that you can note down at your own level as well. And in this particular course for the power plant engineering, the bare minimum things that I expect to be written in your notebook, I will be dictating those points as and when I feel it convenient, or when I feel it that is to be of prime importance. So you should note down those points, and the point that you feel, yes, I should note down that one, you are free to note in your notebook as well in the forthcoming sessions. Okay. Now starting with the topic at the very tentative level, very general level, very broad level. The energy is the essential building block of an economic development. Now, even though that we say that the food, clothes, and shelter, these are nothing but the three fundamental needs or the basic needs of a human being. Okay, since yes, we say that these are the basic needs, food, clothes, and shelter. But if we see that even these three fundamental needs can't be satisfied, can't be achieved without the without the availability of an energy. So energy forms the backbone to satisfy our basic needs, our fundamental needs in turn in the modern time that I am speaking. So that's why it is said that the energy is an essential building block of an economic development of a nation or a country. It is nothing but an important input for improving the quality of the life. So definitely we can say that the quality of the life or the standard of the life is definitely affected or governed by the energy that you are having at your level, isn't it? So the power is considered to be the core industry as it facilitates the development across the various sectors. Energy is nothing but the capacity to do the work, and power is nothing but the rate at which you are consuming that energy. So energy, that is in joule, power, that is joule per second, that is nothing but the watt or kilowatt. So it is considered to be a very important one, the availability of the power, because it drives the different sectors of an economy. So what are the different sectors of an economy which are heavily dependent, extensively, exclusively dependent upon the availability of an electrical energy, availability of the power? So those sectors are nothing but the manufacturing sector. Large amount of the energy power is required for the driving of a manufacturing sector. Agriculture, modern day agriculture requires a large amount of the energy. The operation of your water pumps and the commercial enterprises, the offices, then your transportation sectors, that is nothing but the railways, road transport, waterways. So all these are nothing but the different sectors where the abundant amount of the power or the energy is required, because all these sectors are nothing but the driving forces for a national economy. The consumption of an energy pattern is one of the indicators of the high standard of living across the world. Larger being the per capita energy consumption, so we can definitely say that it is having the good standard of living. So that is directly proportional. So standard of living is directly proportional to the availability of the energy or the pattern in which the energy is being consumed by that particular nation. Okay. So this is what the last line indicates. The energy consumption pattern is one of the vital important indicator of the better or the higher standard of living across the world. Obviously, we can see that toward the western part of the world, the United States and the European countries, they are having the very higher energy consumption pattern, and that's why the standard of living is very rich, very high as compared to that of the Asian countries or the what you can say the South American and the African countries, isn't it? So these parameters would be coming in the further parts of the discussion as well, right? Now, whenever we are saying that our subject is dealing with the power plant engineering, so we are dealing with the generation of an electricity. What different establishments are available? What different types of the power plants are available for the generation of an electricity? Electricity is considered to be one of the cleanest forms of the energies which is available to the end user. The generation, the distribution, and the transmission of the electrical energy can be easily controlled. It can be easily regulated as per the requirement. That is one of the major advantage of an electricity. It can be easily regulated. So the different types of the power plants are available for the generation of electricity. So at very general level, with the very broad level, the two types of the power plants are highlighted in this slide. One type of the power plant, conventional types of the power plants, which make the use of the conventional fuels, fossil fuels, and another are nothing but the non-conventional power plants, okay, which doesn't make of use of any fossil fuel, rather we'll say, or renewable energies are used for the non-conventional types of the power plants. As far as the conventional types of the power plants are concerned, So some of the power plants are listed there on the left hand side: thermal power plant, diesel power plant, gas turbine power plant, hydroelectric, nuclear, and the combined cycle power plant. Combined cycle power plant, it means that you can combine the thermal power plant with the gas turbine power plant. That way, the thermal power plant may be using the fossil fuel. Either it may be the coal base, either it may be the oil base, or either it may be the gas base. So any form of the fossil fuels may be used for the operation of a thermal power plant. Thermal power plant alternatively called as the steam power plant. And I will also say that the nuclear power plant is also nothing but a one type of the steam power plant, isn't it? Because it is the nuclear fuel, nuclear reactor that is used to convert the water into the steam. Whereas in the thermal power plant, a boiler is used, and where you are burning the fossil fuel, coal, oil, or gas, and the energy generated by the burning of these fossil fuels, by the combustion of this fossil fuel, is used to convert the water into the steam. Isn't it? So that way we can say that the thermal power plant and the nuclear power plant are essentially nothing but the steam power plants. And as they are being the steam power plants, so they would be operating on the same thermodynamic cycle. Same thermodynamic cycle, it means the Rankine cycle will be used for the operation of the thermal power plant. Rankine cycle will be used for the operation of the nuclear power plant. Is that fine? Then the non-conventional types of the power plants. So those are listed there onto the right hand side of this slide. Solar thermal power plant, which make the use of the solar energy for the generation of an electrical energy, electricity. MHD, magneto-hydrodynamic power plant. Biogas or the biomass power plant. Geothermal power plant. Ocean thermal, the tidal power plant, and the wind power plant. So these are nothing but the different types of the conventional as well as the non-conventional power plants which are used for the generation of an electricity. Okay. Now the electricity which is say generated, or the electricity that is available for us. So there are the three major pillars of the power sector, we can say. And most of the electrical power generation that is governed by the Ministry of Power, that is nothing but by the central government. And the three sectors that we can say now in the modern times are nothing but the generation, transmission, and distribution. We can easily see that as far as the state electricity board is concerned for the Maharashtra. So we can have the three different companies for the Maharashtra state electricity board. Mahagenco, which generates the electrical energy. Mahatransco, which transmits the electrical energy. And last one is nothing but the distribution company, Maharashtra State Electricity Distribution Company Limited. So see that in your electricity bill, so you may be having that one, Mahadiscom, that is nothing but the Maharashtra State Electricity Distribution Company Limited. So these are the three different ways by which the energy state electricity board or the energy boards are normally distributed. And as far as the generation of the electricity is concerned, so there are the three different sectors, or there are the three different players, we can say, three different agencies are there which are involved in the power generation. The central sector, which is normally covered or governed by the central government, the government of India, which operates across the different states in the country. Then the state sector, it means that the concerned state electricity board, Maharashtra State Electricity Board, then State Electricity Board of Gujarat, State Electricity Board of Karnataka. So that likewise the different state electricity boards across the different states. So they are having their own power plants. Then considering the ever increasing need of an electricity, because the demand that is going on increasing continuously, consistently, the huge demands in the coming days, or say in the coming future, 10, 15, 20 years down the line. So the state boards and the what you can say, the central government may not be in a position to bridge this demand supply gap. So it is essential that some boost must be given there for the private sectors as well, private companies as well, to play their role to bridge or to reduce the gap between the demand and supply. So that is the third player which is involved in the generation, transmission, and distribution of an electrical energy. That is nothing but the private sector or the private companies. So we can have the three different companies: the companies which are operating at the central level, governed by the government of India; then the state electricity board, which are governed by that particular state government; and the private sector. So the different licenses are given by the central and the state governments for the private agencies to install their own setups, generate the electricity, and sell them to the consumers at the competitive rates, so that it would be affordable to all of us. We will be looking at the different companies which are involved at the role of these companies at the central level, the role of the company or the board at the state level, and the role of the private sector in the coming slides. Maybe after the discussion there onto the central sector, we can have the say the full stop as far as the today's session is concerned. And in the coming session, maybe we will be taking this discussion to the next level from the state sector onwards. Okay. Now these are nothing but the different central sector power corporations which are operating in India. Now these different power companies or power corporations are established by the government of India, and they are having their plants across various states in India. And as far as the total power generation is concerned at the national level, so these different types of the corporations, they contribute nearly 25% of the total power generation. So 1/4 of the power which is generated is there from the central sector. We have mentioned the three sectors at the beginning: central, state, and the private sector. So the contribution which is there from the central section, central power corporation companies, so that is around 25%, 1/4 of the total energy generation. So these are some of the different central power companies: National Thermal Power Corporation (NTPC), National Hydroelectric Power Corporation, that is NHPC, Nuclear Power Corporation of India Limited (NPCIL), Rural Electrification Corporation, Damodar Valley Corporation, Northeastern Electric Power Corporation Limited, Central Power Research Institute, which is located in Bangalore, Nathpa Jhakri Power Corporation Limited. So these are some of the companies. The list is not only restricted to this one. There would be more as well, which would be say playing the role at the central level or the national level as far as the energy generation, electricity generation is concerned. And I would like to mention one point here toward the end of the today's session. That large number of the technical people or the engineers are required in the operation of all these types of the power plants. And the recruitment is normally done at the national level. So you should rather I would insist all of you that you should see what the requirement is there, what minimum skill are required as far as the mechanical engineer is concerned, so that he or she can play the part in operation of these different power corporation, power companies at the national level. Is that fine? So as far as the today's session is concerned, I hope that the last 2-3 minutes are remaining. So instead of starting with the next point, in this particular session, I will take the full stop here for the today's session. And if you have any questions in your mind, any difficulties that you are having, so you definitely can contact me either there on my number, or you can mail me, that is provided at the beginning of this PowerPoint presentation as well. So feel free to ask any doubts, any help that you need as far as our subject is concerned. So I will take a full stop for this today's session.